March 14, 1935, Highway 1, California. A 1,000-foot cliff face drops straight into the Pacific Ocean, and somewhere in that vertical maze of rock and ice plant, a road needs to exist. The state highway engineer stands at the edge looking down. The wind coming off the water carries salt spray 300 feet up the rock. Below, waves hit stone with enough force to shake the ground beneath his boots. Someone has to carve a roadbed into this. Someone has to do it without killing everyone involved. The problem isn't new. For 2 years, crews have been trying to extend Highway 1 down the Big Sur coast. Progress measures in feet per week, sometimes feet per month. The cliffs don't cooperate. Traditional cut-and-fill methods require men on ropes, hand-drilling blast holes into rock while suspended over nothing. One cable failure, one moment of inattention, and a worker vanishes into the surf below. The Highway Commission has already lost 3 men. The contractors have lost 5 more, though. And they've completed maybe 6 miles of the planned 72. The conventional bulldozer can't help here. Picture the machine as it exists in early 1935, a Caterpillar 22 or a Best 30, both equipped with straight blades mounted perpendicular to the machine's center line. Push dirt forward. That's it. That's what the blade does. On flat ground or gentle grades, this works fine, but here on Highway 1, the terrain doesn't offer flat ground. It offers exposure. Slopes that tilt 30, 40, 50 degrees toward empty space. A straight blade catches material and shoves it forward, which means straight off the cliff. The operator sits there watching tons of excavated rock and soil cascade into the ocean, taking his workday with it. Worse, the blade's straight orientation creates resistance. The machine has to fight the hillside with its full surface area. The track treads slip. The engine labors. The whole rig threatens to slide sideways, taking the operator with it. LeTourneau sees this problem and decides to solve it. He's 36 years old, running a small earth-moving equipment company in Stockton, California. No formal engineering degree. Dropped out of school in 8th grade to work in iron foundries. Taught himself welding, hydraulics, mechanical design by building things until they worked. By 1935, he's already known in construction circles for unconventional solutions. He designed the first electric drive scraper. He builds machines that do jobs everyone says machines can't do. LeTourneau visits the highway site in February. He watches the crews work for 2 days straight, sees the angles, calculates the forces, talks to the operators who've been trying to cut shelf roads into these cliffs. They tell him what they need, some way to push material sideways instead of forward, some way to work the slope without sliding into the void. He goes back to Stockton and starts welding. The modification seems simple once you see it. Take the standard bulldozer blade, 5 tons of curved steel plate mounted on the front of a Caterpillar Diesel 60, and change its angle. Instead of perpendicular to the machine's center line, mount it at 25 degrees offset. Now, when the tracks push forward, the blade doesn't fight the material head-on, it cuts at an angle. Material slides along the blade's surface and spills to the side, away from the cliff edge. Away from disaster. But the engineering isn't simple at all to us. That 5-ton blade creates enormous lateral forces when angled. The mounting brackets from a straight blade configuration won't hold. They'll shear right off. LeTourneau has to redesign the entire blade attachment system. He uses trunnion bearings, heavy cylindrical joints that allow rotation while handling radial loads. He reinforces the A-frame that connects blade to machine. He adds hydraulic cylinders that let the operator adjust the blade angle while working, anywhere from 0 to 45 degrees depending on conditions. The hydraulic system alone weighs 900 pounds. The prototype comes together in 6 weeks. LeTourneau fabricates everything in his Stockton shop: blade, brackets, hydraulic manifolds, control linkages. The blade measures 12 feet wide and 4 feet tall. 1/4-inch steel plate bent to a specific curve that LeTourneau calculated will shed material efficiently without catching or jamming. The whole assembly mounts to a Caterpillar Diesel 60, a machine that weighs 32,000 pounds empty and generates 67 horsepower at 850 RPM. March arrives. LeTourneau loads the modified bulldozer onto a flatbed truck and hauls it down to the Highway 1 construction site. The highway engineers look skeptical. The contractors look worse than skeptical. They've seen plenty of equipment fail on these cliffs. They've buried men who trusted machines that couldn't handle the conditions. Why should this one be different? LeTourneau puts his own operator in the seat. The demonstration run targets a section of slope that's been defeating crews for weeks. 40-degree grade, loose decomposed granite over solid rock, exposure straight down 900 feet to the surf, the kind of place where even walking feels dangerous. The modified Diesel 60 climbs up to the work area. Engine sound bounces off the cliff face. Tracks chew into the slope. The operator drops the angled blade and starts cutting. The difference shows immediately. Material slides along the blade surface exactly as designed, spilling upslope instead of over the edge. The blade cuts into the hillside at an angle, creating a shelf. The machine doesn't fight the terrain, it works with it. The operator makes one pass, then angles the blade further and makes another. Each pass moves tons of material sideways. Each pass widens the shelf. The machine isn't sliding, the tracks hold. In 30 minutes, the modified bulldozer cuts a roadbed section that would have taken a crew 3 days to hand drill and blast. If you want to see how this one modification revolutionized construction on impossible terrain, hit that like button. It helps us share these engineering stories. Subscribe if you haven't already. Back to that cliff in 1935, the highway contractors place an order before LeTourneau's operator even shuts down the machine. They want 6 units immediately. They want 12 more if the first 6 perform. LeTourneau goes back to Stockton and starts production. By June, 8 angle blade dozers are working on Highway 1. By September 15, the rate of highway completion jumps from feet per week to hundreds of feet per day. Other contractors notice. Word spreads through the heavy construction industry. That machine LeTourneau built, the one that works cliffs nobody could work before, becomes essential equipment. Orders come in from dam projects, from mining operations, from highway departments across the western states. LeTourneau's shop goes from building custom one-offs to manufacturing production units. The angle blade dozer becomes standard equipment, not specialty gear. The technical impact extends beyond just moving dirt on slopes. The angled blade creates a new capability, precision grading. Before this modification, bulldozers were blunt instruments. They pushed material. They didn't shape it. An angled blade operated by a skilled operator can cut exact shelf roads, can create specific drainage grades, can build roads that follow natural contours instead of fighting them. The machine becomes a tool for finesse work, not just brute force. Highway 1 gets finished in 1937, 72 miles of road carved into cliffs that people said couldn't be built. The route runs from Carmel to San Simeon, including the section at Big Sur where LeTourneau demonstrated his modification. Total project cost, $10 million, about half of what engineers estimated before angle blade dozers entered service. The time savings came from eliminating hand labor on exposed slopes, from reducing the need for explosives, from letting machines do work that previously required dozens of men on ropes. LeTourneau's company grows. By 1940, he's manufacturing earth-moving equipment that goes to construction sites worldwide. His designs influence every major equipment manufacturer. Caterpillar adopts angle blade technology. Allis-Chalmers follows. International Harvester develops their own version. The basic concept, mounting a blade at an adjustable angle to the machine's centerline, becomes industry standard. Modern bulldozers still use variations of LeTourneau's 1935 design. The military takes notice too. When World War II starts, the U.S. Army needs to build roads, airstrips, and fortifications in every kind of terrain. Pacific Islands with volcanic slopes, North African desert with unstable sand, European countryside with muddy hillsides. Angle blade dozers prove essential. The Army orders thousands, the Navy orders more. LeTourneau's factories run 3 shifts, 7 days a week. His companies produce equipment that builds the infrastructure for the Allied advance across multiple theaters. After the war, the construction industry enters an expansion boom. Interstate highways, suburban development, dam projects, mining operations all require earth-moving equipment that can work challenging terrain efficiently. The angle blade dozer becomes as common on construction sites as the pickup truck. Every major project uses them. Every contractor owns them. The machine that started as a solution to one specific cliff in California becomes fundamental to modern construction. LeTourneau himself keeps innovating. He develops the first rubber-tired dozers. He designs machines that can load, carry, and dump material without assistance. He builds scrapers that revolutionize large-scale earth-moving. His company eventually becomes one of the largest heavy equipment manufacturers in the world. But it all traces back to that moment in early 1935 when he looked at a cliff that defeated every conventional approach and decided to angle the blade. The Highway 1 section at Big Sur still exists. Cars drive past those same cliffs every day, most people never knowing how close that road came to never being built. The slopes where LeTourneau's prototype proved itself are still there. 900 feet of vertical drop to the Pacific. The kind of terrain that says no to easy solutions. The kind of place where engineering either works or kills people. That 5-ton blade changed what became possible. Not through force, through geometry. Through understanding that sometimes you don't push against resistance. You angle past it. You let the blade's orientation do the work. It's a principle that extends beyond bulldozers, beyond construction. When you face impossible terrain, maybe you don't fight it head-on. Maybe you approach from an angle. If this story made you see engineering differently, hit the like button and subscribe. Your support helps us preserve these technical histories. Tell us in the comments where you're watching from. Thanks for being here.